Okay guys, I wanted to go over the 3 different gas laws here to make sure that you guys know what we're talking about, because this is basically section 3 through section 5, so 3, 4, and 5. We had Boyles Law, which stated that your initial pressure and your initial volume is equal to your final pressure and your final volume. So as one increases, the other goes down. So these are opposite. Maybe as pressure increases, then your volume will go down. So they're opposite of each other. And that's Boyles Law. Now to do an example problem of that, let's just say that I have 2 ATM and I have a volume of 2 liters. And let's say that they tell me that my final pressure, that I now have a new pressure of 3 ATM, and I want to know my new volume. I am going to divide by 3 on each side. Alright, so that cancels out. With my volume now being, let me grab a calculator real quick. I'm going to, 2 times 2 is 4, and I'm going to divide that by 3, which would be 1.3, and it is volume, so it's going to be liters. Right, so that is Boyles Law right there. So then we had Charles's Law, which let me grab that real quick here. Which Charles' Law, I believe, was pressure, getting them mixed up here real quick. So we had Charles' Law. And that would be, Charles' Law and Gay-Lussac's Law is very similar. I'm thinking this is pressure, but either way, I want to show you guys, hey, this is the second gas law. This is how you set it up. This is how you would solve for it. Now here, these are going to do the same. So anytime you see temperature, they're going to do the same thing. So as temp increases, then my pressure will also increase. Or as temperature decreases, then your pressure decreases. All right, so now then, temperature. This has to be in Kelvin. As I was looking at this last worksheet, a lot of people were not putting that temperature in Kelvin. You're going to add 273 to your Celsius. So let's say that for an example problem, they tell you, hey, you have an initial pressure, and I'm going to use millimeters of mercury because that is a possibility. They may not give it to us in ATM, but let's say they tell me that I have 1,500 millimeters of mercury. That's my initial pressure, and my initial temperature is 30 degrees Celsius. And then they say, okay, you change your temperature to 50 degrees Celsius. What is your new pressure? So the first thing that I am going to do is I'm going to change this degrees Celsius to Kelvin. So I'm going to take 30 plus 273, and that is 303. Okay, that is the number I'm going to use here. I'm going to use 303 there. Then I'm going to take 50 plus 273. And that is 323 Kelvin. That is the number I'm going to use here. So what I really end up with is 1,500 divided by 303 equals, I need to find my new pressure, over 323. This is in Kelvin. Our temperatures have to be in Kelvin or we aren't going to get the right answer. All right, when you see these, you are going to cross multiply. So you're going to take 1,500 times 323. And that gives you like 4.64, blah, blah, but whatever is left over, whether it's your temperature that we have this time, 303, or maybe they gave us P2 and we're trying to find the temperature, whatever is left over, you're dividing by. So I'm going to divide by 303, and that is 0.15. Well, that makes no sense. Let me, 1,500 times 323, oh, it's 484,500, sorry. And I'm going to, as I said, this number makes no sense at all. And I'm going to divide by 303. And I have 1,599 millimeters of mercury is my new pressure. Gay-Lussac's is the exact same, only instead of pressure, we're going to talk about volume. All right, so I've got V1 over T1 equals V2 over T2. And anytime you see temperature, what one does, if temperature increases, then my volume is going to increase. If my temperature decreases, then my volume is going to decrease. All right, so if I do a sample problem, it's going to be like up above. First off, I need to make sure my temperature is in Kelvin. So let's say that they tell me, hey, you have 5 liters volume, and you have a temperature of 0 degrees Celsius. You change your liters, you change that to 10 liters. What is your new temperature? Now this is assuming that pressure is staying the same, that we're not messing with we're not changing pressure on our end. So when I do this, first off, I cannot have 0 here. I know that, I think I saw this on a few where you guys had 0 and you didn't change it to Kelvin, so 10 times 0 is 0, divided by 5 is 0, so your answer was 0. So I cannot have this. I need to add 273 to that, so it's 273 Kelvin. So now I'm going to take 273 times 10, and I'm going to divide by my number that is left over, so I'm going to divide by 5. So my new temperature is 546 Kelvin. Now if they asked you what is that in Celsius, I would subtract 273 from that number, and that would be my answer in Celsius. All right, guys, so that was just a real quick review, recap on those 3 different laws. If you need anything else or have any other questions, please let me know.